Alrighty. Earliest and latest rounds where players beat hard. Based on my confidence from beating some of the hard ones recently, I'm gonna just try to do this kind of blind. Okay, there's a tournament where N players are participating. The players are standing in a single row and are numbered 1 to N based on their initial standing position. Player 1 is standing in row. Player 1 is the first player in the row. Player 2 is the second player. Okay. The tournament consists of multiple rounds. In each round, the ith player from the front of the row competes with the ith player from the end of the row. Okay, so like 1 versus 64, 2 versus 63, if n is 64. Sure. And the middle player, if there is one that can't be paired, advances. Okay. After each round is over, the winners are lined up in the row based on the original ordering assigned to them initially. The winners. Okay. Players are numbered first player. Players are numbered first player and second player are the best in the tournament. They can win against any other player before they compete against each other. If any two other players compete against each other, either of them might win and thus may choose the outcome of the round. Given an integer n, first player and second player return an integer array containing two values, the earliest possible round number and the latest possible round number in which these two players can compete against each other respectively. What is happening here? N is 11. Alright, and yeah. N is 11. 6, 7, 8, 9, 10, 11. The first player is 2, the second player is 4. They can win against any other player before they compete against each other. If any two other players compete against each other, either might win. Okay, so return the integer array containing two values, the earliest possible round number and the latest possible round number in which these two players compete. Interesting. So initially 2 is going to go against 10. Okay, so the pairings in the first round here will be 111, 210, 3, 9, 111, 210. How do I write this? 111, 210, 3, 9, 4, 8, 5, 7, and then 6 gets a bye. So we know that 2, so it's 2 and 4 that will automatically win against them. And eliminated is 10, 8, and 10. So is it possible for them to play in the second round? I don't think so. So 6 is also going to be in this in here. So it's like 1, 1, 3, 5 would be the earliest thing here. 1, 3, 5. In order for them to pair up in the second round, then 2 is either going to be the first pairing or the second pairing, and 4 can't really be the second to last pairing. So it's not possible in the second round. It should be possible in the third round though, right? Just has to be some way of getting that. So I think maybe we did 1, something like this. 2 is going to beat 5. Oh, I need one more. So if everyone won, yeah, I think this works. Four might be the largest. I need to eliminate the one. Yeah, so I think it should be, well, obviously it's like 1, 2, 3 versus 6, 5, 4. If the 2, oh jeez, I guess it's like 2, there's going to be 3 winners here. The bye goes to the middleest person. So the middleest person can't be either the 2 or the 4, has to be. So the biggest and the smallest has to be 2 and 4. But 2 and 4 can't be the biggest and the smallest simultaneously. So the only way the biggest and smallest could be 2 4s if 3 wasn't there. Alright, let's just rearrange this. Move 3, get the 9 in here. Okay. That still doesn't work. The only way that the 3 can be the middle, no, 3 has to be there. I think. Then what's the other stuff going to be? The 1 has to get away, so maybe 11. Yeah. And then the winners there would be 2, 3, and 4. Okay, so first round, second round, third round is the earliest that they would see each other. Okay, yeah, that's right. And the latest they can see each other is the last round. Interesting. It's quite complicated. First player is 1, second player is 5. They get paired together in the first round. There's no way to make them beat the other round. What? What the heck is going on? Oh. Constraints, there's 28 players. Interesting. 28 players means fit 5 rounds at most, right? I wonder why they chose 28 to be honest. Why didn't they just go with the full 32? 2 to the 5th is 32. 2 to the 1st is 2. So 1 round you can do 2. Yeah, so 5 rounds you should be able to do 28. Seems like a backtracking one to be honest, because backtracking generally requires a fairly small set of possibilities in order to do like n factorial possibility search through it. Otherwise it's too large if it's too big. And I think 5 rounds means maybe 5 factorial, maybe that. Although it seems like it might be possible to do something faster. Maybe. Don't really want to do a simulation where I try every single combination of picks who. Okay, let's so the return is a 2D array of min versus max rounds, earliest versus latest. How would you simulate something like this? So you know the first round matchup, so that's going to be fixed. And you know 2 of the winners in that. No, well, 2, it could be 1, I guess, if they paired it against each other. I guess maybe I can just do the trivial case. So the trivial case would be if first player is does first player have to be smaller than second player? Okay, yeah, yes. So if first player equals like n minus I guess n minus second player. Yes. 1, 5. I guess if second player is equal to n plus 1 minus first player, then return 1, 1. So that's kind of trivial case. Players are paired in the first round. There's 1 versus 10, and 10. Yeah, I think that's right. The plus 1 is necessary because you're not dealing with 0 indexing. Even if you are dealing with 0 indexing, I think maybe if you're doing with 0 indexing, then maybe you need n minus 1. So like 0 and 3 gets paired off. There's 4 in first player, 0 and there's 3. So it would be 4 minus 3 minus 1. Anyways, what else I can do? So if I know, so if at this point they're not paired off in the first round, then I know two of the winners from the first round. And I can choose pairings here. There's going to be at most 12 question marks because n is less than or equal to 28. 28 means there's 14 winners, or 14 people that can be at most going to round 2. 14 minus 2 is going to give you 12. So I have 12 things I can choose from. I have 12 things I can choose from. Or I guess maybe that's the wrong way to think about it. I have 12 numbers to fill here, where each number has a choice of 2 priors. Guess maybe I can try to reverse engineer it based on the number for participants. I should know exactly how many rounds it takes and how much, or not how many rounds it takes, but at most kind of the number of rounds you'd get until 2 are left, and you can backtrack it to like the size of each round. So if n is, what was it, 11? N is 11, then round 1, n is 11, round 2 is 6, round 3 is 3, round 4 is 2. So it's the rounded up value of divide by 2. And I guess round 5 only occurs if you actually have exactly, well, let's see, n equals 28, round 1 is 28, round 2 is 14, round 3 is 7, 4, 2. Okay, so I guess anything above 16 should be 5 rounds at most. So like n equals 17, round 1 is 9, 5, 3, 2. What? What's the threshold to get to round 2? What's going on here? Oh, that's so stupid. I started with round 1 being 17. Or it should be 17 here. 9, 5, 3, and 2. Okay, so 17 is the cutoff. For the most rounds being 5. Oh, I guess the min cutoff. 16 is the cutoff for being 4. So if I backtrack it, let's say I have 2 and 4 as the winning, as the first and second player, and I know that the n is 17 or n is 28. Can I just logically deduce what it should be? So 2 4s here. Only way that those two get paired up is if there's 3 in round. Maybe this is the wrong way of saying this. So it's going to be 2 4. Only way that they get paired from round 4 is if I wonder if I screwed up on my calculation there. Yeah, I think I screwed up here. It shouldn't be 2 3 4, that was the goal. It should be like 1 2 4. So it could be 2 1 2 4 as long as 2 is the middle number. I guess 2 could be the middle number or 4 could be the middle number. So let's try the simplest one or the earliest one, 1 2 4. So so here 1 2. There must be 5 numbers here. So 1 2 4. Just making random numbers. 1 gets paired, 2 gets paired. Yeah, so it can't be 3 4 here because then 2 and 4 would get paired up, so it has to be 4 here. And then some bigger number, maybe like 5 and 6. Just trying to use the lowest number possible. So 9 here. 1 2 4 5 6, and then I don't see why 7 can't be here. 7 8 9. So just 3 has to be, well, 3 has to be eliminated at some point. So the 3 pairs with the 3 pairs with the 1 pairs with 17 to 16, so they add up to 18, so 3 pairs with 15. So I think this thing needs to be like 15 here. No, I think there has to be a 9. Yeah. And here would be 1. Well, this is everything. 1 through round 1 has 17. Yep. So this is 1 through 17 right here. So here 1 versus 15, 2 versus 9, 4 versus 7, 5 versus 6. I'm missing another pair. Maybe it should be 9 things. 1, 2, 3, 4, 5. Yeah, something like this. The only thing that didn't win that was an early number was 3 here. And then those 9. And these 1, 1. And then these guys 1. I wonder, when is it like not possible to kind of get the delayed? Why is it not possible to reach the maximum? Under what circumstance? Like, I guess if it was... So when do you have to pair it in the second round? What would be the setup? So if it's 17, you know your middle number is going to be automatically there. So you're like 9, if it's an odd thing, 9 has to be there. Right. 8 gets paired with 10, 9 gets not paired. So 9 is there. So if you had a middle number, you had a number that was right dab in the middle based on the first pairing, and then your other number was like a 1, then you would have to pair it up in the second round. Otherwise, I don't think you have to pair it up in the second round unless I'm missing something. So if your winning numbers are your smallest 2 numbers, and they're probably not going to get paired in the second round unless there's only 2 things in the second round. If your winning numbers are your smallest 2 numbers, you should always be able to pair it at the very final round. Or really, yeah, if they're the smallest 2, then they'd never get paired until the final round. So I could do trivial case. Paired in first round. If lowest numbers. Only paired in last round. Last possible round. If n is odd, and numbers are 1 and middle, lowest, median. No, it's not median. Yeah, median actually. Always paired in the second round. Okay. Actually, does it have to be the median? It could also just be 1 in a middle number, because it's like 20 and your thing was like 10 and 11. 10, 11? Yeah, 10. Second number is 10 and 11, then they would go into the second round as the last number in that bracket. So that should be paired with the 1 and middle number. Yes, it doesn't have to be odd. What else? What else? So, yeah, let's keep that. So, how do we construct it? There might be a formula for this, to be honest. My sense is like, yeah, there feels like there might be some sort of formula rather than some simulation as to picking numbers and then figure out lowest and highest possible. Alright, so so if it's 17, like 117 to 16 are the first round pairings. And then the things that can guarantee a second round pairing would be like 1, 9. Is there any other guaranteed second round pairings? I guess if they're the middle number of this thing. There's 9 numbers here. Can you guarantee the 2 middle numbers? So, wait, this is wrong. No, the middle number doesn't actually, that's not true at all. The middle number isn't necessarily the last number in the second round. So I guess if it's 1 and the second to last is like if it's 17, if it's 1 and 16, you're guaranteed the 1 is going to be the first in the second round, you're guaranteed the 16 will be the last in the second round. So then they're actually guaranteed to be matched up. 1 and 9 is actually never going to pair up in 17. Actually, yeah. It's 1 and second to last. So what about 2 and its last? Yeah, 2 and last could also work. Or 2 and last. Let's say 1 comma n minus 1 is second to last, or 2 comma n. Yeah. What about 3 comma n minus 2? I don't think that works. Because you're not guaranteed to know where the 3 would land. 3 could land first, second, or third. Here you're guaranteed that the first is eliminated by the last n, the nth player. So therefore 1 is not going to be part of the second round. And so the 2 is the first number in the second round, and n is the last number in the second round. So let's say 3, if I do n is 17, is there anything else that guarantees a second round ending? So if it's like 3, 17, 2 could be there. So 3 would be the second to last, or second earliest, or 2 would be the second earliest, or 2 could be the earliest and 3 could be the second, and then so 316 also doesn't work. 316. Yeah. So think 117, 216, 315. So if it's 317, then it could be 2. 17 is a pretty big number. 2, yeah, it could be 217 in the second round. 316. 316, it could be 116 in the second round. Yeah. Okay. So, but it does seem like even if I can't do it in the second round, I have to do it in the third round. Like, there's no way to not do it in the third round. Yeah, so let's say the things were like 3 and some big number. Say 3 and 16. So I have 117 paired, 216, and 315. After the first round, say the 1 1. Be 1, 3, and then 16 is the last. 17 is eliminated by the 1, 16 is eliminated by the 16, 2 is eliminated by the 16, and 3 is eliminated by the 15. So at that point, 16 would be the first, 16 would be, 3 would be the first, and 16 would be the last in the next round. So the third round would guarantee that matchup. So this is round 1, and then this is round 2, and this is round 3. And I don't think we can get paired up in round 2 at all, so this is kind of both the max and the min. So test case, n is 17, 3, and 16. I think this should be 3, 3. Yeah. Yeah. What does that mean, though? If you can I backtrack this? No. So how would backtracking work here? So I can try to assume that round 5 starts with 316 and somehow reach a logical reach a logical contradiction. So if I started with 316 in round 5, then round 4, which has, so I know the sizing here. Sizing is 3. So round 4, which has 3 of them, needs to have 316 as like the last 2, the first 2 in that bracket. If it was the last 2, then it'd be like 1 316 or 1 216. 1 216 doesn't work because 16 2 gets paired. So round 4 is either round 4 has to be 1 316 or it could be 316 17. If it was 3 and 16 as the first and last, then they get paired up. Can't be 2. 2 is already eliminated. And then prior round to that would be 5 numbers, where the 5 numbers have 5 numbers. Let's have like 16 as the middle number. No, that's not true. So there's going to be 5 numbers, of which 3 of those numbers are the 3 numbers, so 1 through 16. So if it's a middle number between here and here, then 3 and 16 get paired. So it has to be something like this, or 1x3 16x. Interesting. 1 has to be the first number, so 3 and 16 has to be the other 2 of the other 4 numbers. The 16 can't be the last number because that means it would pair up the 1. So 16 has to be the second to last number or the middle number. If 16 is the second to last number, then you can't pair it with 3, so 3 has to be the middle number. If 16 is the middle number, then 3 has to be the second number. And the only way this works is if 2 is here, and 2 is already eliminated in the first round. And this only works if there was 2 numbers bigger than 16, but n is 17. The logic here is just kind of brutal. Or the logic I'm thinking of is kind of brutal. There's a simpler logic. So anyways, the contradiction is like, this thing's not possible. And I assume it's going to be very similar for 3, 16, 17, but nothing's not going to be possible. Yeah, the thing's just nothing possible. Like the 3 has to be the middle number, and therefore there has to be 2 smaller numbers that get paired with it. So it has to be like 1, 2, 3, 16, 17. Or the 3 was not the middle number, then 3 would be like the second number, in which case it would get paired with the 16. Or 3 is the first number, in which case it gets paired with the 17 in that round. So anyways, it's not possible for this thing to work. So therefore it's not possible for there to be 3 rounds at all? It's not possible to construct 3 rounds where you start off with 2 and go to 3. So it has to be something bigger than 2. I guess it could still be something that starts with 3. So construction doesn't work right there. So if you start off with 2 and try to construct backwards, your contradiction is just going to prove that it's can't be. You can't start off with that small as the set. You can't start off with 2. So the contradiction is purely on the assumption that there's 5 rounds. So you're just proving that it's not 5 rounds. You're not proving that's 4 rounds or 3 rounds. Exactly. Ugh. Going backwards doesn't quite even give you a full answer. So I'm gonna say that there should be just some formula for this. Some formula for this. What is that formula? Okay. Let's say winners always win. Oh, let's say smaller number always wins. And that's maybe the tie break if it's ambiguous. Alright, so 1, 2. This is last round. This is round 5. 1, 3. 1, 3. This is also round 5, I'm pretty sure. 1, 4. I'm pretty sure you should always be able to construct round 5s off these. So when am I thinking that's not round 5? I think, well, it's round 5 at the max. At the minimum, minimum 1, 2 is round 5 is the minimum as well. 1, 3 at the minimum. Is it possible that they get paired up in round 4? Yeah. If in round 4 the round pairings is the numbers is 1, 2, 3. So this is probably round 4. Well, okay, so the pairings here would be 5, 5. This is 4, 5 at the 4 at the minimum, 5 at the maximum. I think this would be 4, 5 as well. Yeah, this is 4, 5. Let me think of this. Yeah. So when is it not 4, 5? Oh, let me double check that one. 17, 1, 5. It's actually 3, 5. Okay, what about 1, 4? Oh, okay. 3, 1. Oh, this is 3, 5. Let's just dive into that one, I guess. So round 5. So how would I construct it so that it only goes 3 rounds here? Okay, if it only goes 3 rounds, then in the 3rd round it'd be 1, 5, 1, 1, x, 5. The 1x5 in the 3rd round. I guess it, huh. No, wait. In the 3rd round, there's how many? There's 3. In the 3rd round, there's 7. No, in the 3rd round, there's 5. I see. Yeah, in the 3rd round, there's 5. So it has to be 1x5. So clearly it could be 1, 2, 3, 4, 5. So therefore we can pair it in the 3rd round. Okay. So bigger than that, 1 can get paired in the, let's say 1, 9 gets paired. This is at minimum 2 with everything. If okay, so I think what I previously wanted to say, if the lowest number, if the numbers are 1 in the middle, then I should be breaking this down. Paired in the 1st round, like returning 1, 1. Min and max. If the lowest numbered, only paired in the last round. So this is, so the last round is L. And this is always paired in the 2nd round. So this is 2, 2. If the numbers are 1 in the middle, then the min pairing is going to be the min paired in the 2nd round. I guess if it's 2 in the middle, 2 in the middle is also minimum in the 2nd round as well, right? Yeah, it's either 1 or 2. Because you could have the 2 be the first thing that is in the list. Actually, if it's any number in the middle, right? Because if it's any number in the middle, then you can force that number to be the first number. Is that right? It's not. No, right? So if you have 9, you can make 9 be the last number, 2 be the first number. No, you can't make that middle number be the last number. 1 in the middle. 1 in the middle means you can have everything that's small 1, and therefore the 1 in the middle number gets paired. If you have 2 in the middle, then to make the 2 be the first number, then the last number is 7. It's like n. And then the 2 doesn't get paired. Guess if it's middle and the last as well. Yeah, middle and last. And then you can get all the big numbers to win. And then the middle number prepared will be the first in the list, and n will be the last. Man, this thing seems so... should be so simple. It'd be so simple. Pairing. Hmm. 1, 9. Yeah, the mid pairing there is 3, 2. What is the way to construct it so that it's like a min pairing, but it gets paired with each other? So if it gets paired with each other, then what has to be true? It has to be the same number away from the start and end in the sequence of things. The same number from the start and end in the sequence of things. And how would you get that to be the case? So if you had a small number, what if I think about each round as eliminating something that gets in that way? Eliminating something that gets in that way. So what if I had 1, 2 always pairs in the last round? Is there the biggest number? Yeah, so 1, 2 is always paired in the last round, or if they're the biggest number, they always get paired in the last round. There's always going to be some sort of complementary rule for these. So why is that the case? Why do the lowest numbers always get paired in the last round? I guess in the grand scheme of things, let's say n is something really large. Let's say n is, yeah, I'm pretty sure, I mean, what feels like to me is like part of the problem is maybe they want you to simulate the answer here. Like do some sort of backtracking to get the answer. I feel like there's a generalization of this problem that's just solvable for any value of n based on the value, well, obviously based on the value of first player and second player, but using some formula to determine when they could meet. So let's say n is something big here. So let's say it's 1 and 2. So what happens here that makes it hard for it to get paired up earlier than the last round? Well, let's say it's actually 1 and 3. Like 1 and 3 here, you'd maybe expect it to be something like 1 and 2 is going to be something like round 10 to the 10th, or 2 to the 10th is 1004, so it would be 10, 10. For like 1, 3, I expect it to be something like 9, 10. Just like that. So the minimum is 9 because if you get through 9 rounds and you get, and in the second to last round where you have, actually that's not true, right? That's actually not true. In the second to last round you have 4. Yeah, if you have 4 left. Actually, this should be 10, 10. I think maybe I should be doing something like 5 and 13. Where there's an odd number here. Odd number could be 1, 2, 3, and you get paired up in 9, 10. You get 9 rounds. And if it's like 1, 3x, then you get 10 rounds. If you have 1024, then in the second to last round you have 4. Okay, actually, let's go ahead and just check something out here. N is, actually I can't do n is 32. Let's say n is 16. So there's at most 4 rounds. You have 1, 3. Is it 4, 4? No, 1, 3 should be 3, 4. 1, 3. The minimum. 1, 3 might be 4 actually. The earliest that 1, 3 can. Yeah, interesting. So n equals 16. 1, 2 is 4, 4. So I think it's 1, 4 that becomes 3, 4. The earliest that 1, 4 could be paired with 3. The latest it could be 4. Because if in the second to last round there's like 1, 2, 3, 4, and the 1, 4 would be paired. Or if the second to last round was like 1, 4, and then 2 bigger numbers, then the 1 and 4 don't get paired until the last round, the 4th round. So why is it some things guaranteed to be paired in certain rounds? Guaranteed to have a minimum and maximum pairing in that round. So you know your first round pairings. Know your first round pairings. Which gives a range for your second round pairing. So if there is no range, like 1, 2, there is no range for where it is, or 16 15. There's no range there. And then well, there is no range because like the 1 is always going to be first, and the 2, which could either be first or second, comes in always second because first is fixed. So therefore 2 is always second. Interesting. Interesting. So the 1, 3 here is 4, 4. The 1, 3 here is 4, 5. And if in 16, second to last round, last round has 4. And if the 1 and 3 are there in the second to last round, the 3 could be the first, no, 3 could be the second or third in that 4 pairing, or that 4 group. If it's the second, then it still doesn't get paired with the first, with player 1. If it's the third, it doesn't get paired with player 1. Interesting. Same deal here, kind of. Second class pairings with 3 numbers. Of those 3 numbers, 3 can't be the second number. No, 3 can be the second number. 3 can be the second number, 3 can be the third number. But the 1 gets paired with the third number in that round. So therefore it's 1. One, two, three, 4. 1, 2, 3, 4. Okay. 1, 16. 1 through 16. Like I have a feeling, I have like an image in my head where numbers are in kind of moving around. And each round allows it to be moved around one spot. Each round allows it to be moved around one spot. And it's trying to go to certain spots at the end of the round. So like so if it's, let's say it's 2 arbitrary numbers, let's say 3 and 7. So you have 3 and 7. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you have 3 and 7. And then you have 9 spots in this round. And so the spots were A, B, C, D, E, D, C, B, A. So the 3 could be in spot A, B, C. The 3 can't be any later spot than D because there's not enough spots before it, not enough numbers before to fill those spots. So the 3 could be here, here, here. The 7 could be at latest C. And the 7 could be even earlier than that. The 7 could be, I guess, because there's a 3 that's always there, the 7 could be up to B. So in round 2, these should be able to pair, I think. The 7 should be able to go to, let's say, well, actually, if it's just all small number that swings, then the 7 and 3 could automatically be paired. 3 and 7 here. And let's say it was like 4, 7. It's 4, 7, then it's not automatically paired. But if there was just one, there was, let's say, an upset where the 6 lost to a bigger number, and the 7 gets bumped down to D, and 4 would match with 7. It's, actually, interesting. Okay, I have an idea. Okay, so in for purposes of answer, I think I can say that k and n plus 1 minus k are equivalent. So like for instance, n equals 16, 1 and 2 and 15, 2 and like 16 plus 1 minus 2, 16 plus 1 is 17 minus 2 is 17. Are equivalent because only one of those is going to win, and you really don't care which number wins. So I could remap everything to a smaller number. Yeah, okay, I can remap everything to like the small set of numbers below the middle at any point. So that's why like equivalently 1 and 2 versus n and n minus 1, they have the same answer because I could, well that's not why, but if I think about n being equivalent to 1 and n minus 1 being equivalent to 2, they'll get me the same answer. So that at least simplifies the problem to be if I have two numbers in the smaller half of the set, what is the min and max round that they would be paired? And if that's the case, then I don't have to worry about like anything above 9 or n is 16 or n is 17. Interesting. Right, so let's say those two numbers were 4 and 7. So the smaller the number can always be the first number in the next set. It's strictly true. And the bigger the number can be, smallest is the so this could be at smallest the first and the second number in the next set, or at biggest it could be the last or the second last and the last. No. Actually, was that conclusion right? The purpose of the answer k and n minus 1 plus k is what? Actually, maybe that's not right. Yeah. Just because I can trade places. Don't think it's equivalent. Maybe it is. No, there's no way. Possible? Because they would trade off. Yeah, I don't think that's right, actually. Like they might be able to be equivalent in order matters though. I can't just make the first be the last. Like if I had one n minus one n minus one, it's not the same thing as 1, 2. Gosh dang it. Because 1, 2 gives me the last round. 1 n minus 1. It's not like n minus 1 is the same thing as 2. I think maybe I can trade reflections on both. Yeah, I can do reflections on both. So if I reflect 1, I reflect 2 to be n and n minus 1, the answer's going to be the same. I can't just reflect one answer, so I can maybe do n and 2. Yeah, n and 2. So if reflecting both A and B, or they're the player numbers, across n, reflection of k is n plus 1 minus k. Answer is the same. 1, 2, 3, 4. So I could get something that's where at least one of those numbers is small. Because if both of them are big, then they both reflect small numbers. If one of them's big, one is small, and one is small. So I could eliminate the possibility of having to worry about two big numbers. Big numbers over the middle of K, or middle of N. So I have one small number, another small number, and small number, another small number. How would I solve? The small number could always translate into the first number of the next set. So it's always going to be possible to make the small number number 1. Numbers themselves don't particularly matter as long as, because once you translate it to the next set, you're just working off of the ordering of the numbers in the next set. It doesn't matter what the numbers were originally before the translation. So it just matters the relative ordering. So if you were 1, or if you were something that was not 1 before but translated to 1, translated to the first, and you're equivalently 1 at that point. So that's an idea I probably should leverage. At any point can renumber based on ordering of values in that round. So if a given round had like 4, 5, 6, you could just make it 1, 2, 3 and get the same calculations later on. So just it's purely orders. Of course, I kind of knew that already. So if it's 1 and the second last, they're always going to be paired. Or if it's 2 in the last, they're always going to be paired. 2 in the last just gets to reflect to 1 and second to last, I think. Okay. In order to be paired, they need to be on opposite sides of n. One has to be the smaller number compared to the middle, and one has to be the bigger number compared to the middle. And that's why, like, if you have 1, 2, 1, 2 is never going to get paired until the last round. Or like n and n minus 1, they're never going to get paired until the last round. Yes, another one would be D. In order to be on opposite sides, must have some middle numbers, or same number of smaller / bigger numbers. I guess that's kind of obvious. In order to be paired on opposite sides, So it's like 1, 1, 1, 3. If it's 1, 3, in order for that to be paired, then it has to be like 1 and 3 are the biggest and smallest number, or it has to be exactly 1, 2, 3. Well, that's the same thing, right? Or let's say it's 1, 4. 1, 4 would have to be the biggest and smallest number. So it has to be like 1, 2, 3, 4, or 1, 1, 2, 4, 1, 3, 4. Let's say it's like something like 100 and 100 and 200. It would have to be something like 100, 200, the biggest, smallest number, second biggest, second smallest, third biggest, third smallest, 100 to 300 with 200 and 100, or 0, 1 to 300, 100 and 200 are the kind of numbers. Man, I'm really supposed to actually make a simulation of picking things here. Find the minimum. Need to find the maximum. There just has to be a formula for this shit. There just has to be. It's just too straightforward to not be. So 4, 7. 4, 7, which is equivalent to something like 13, 10, 13, 11. And 14, 14, 11. So you can remove, you can move the 4. Will be the earliest. The second set. How to move things around. 4, 7. wonder if I wonder if I if I think about a number, if you have a number that's a small number, each round it could move a small number each round. It could make itself into either the smallest number each round can make itself into pretty much anything from the first to the middle number of the next round. With the exception that can't make itself into the last number if the second player was also in the front half. Make itself into the first. No, it can't make itself into the middle number. It can only make itself into the smallest itself in the next round. Yeah. So any small number is never going to move to a later spot in the next round. So if you have the third number, or if you have the fourth number, it can move to the first, second, third, or fourth in the next round. Can't move later. Similarly, if you have a big number, you can't move to something that's bigger. Bigger than where it is relative to the last in the next round. So if you have something that's second to last, you can't make it like third to last in the next round. Second to last has to be second to last in the next round. Well, if it's third to last, it has to be third to last, second to last, with last in the next round. Third to last, second to last. Yeah, last. So numbers can shift to a certain extent. They can shift they can move towards the end that they're closer to by some number of spots. They can't move farther away from the end that they're closer to. 3 being closer to the 1 means that 3 can't become 4 or 5 in the next round. 2 being closer to 1 means that 2 can't be 3 or 4 in the next round. 2 has to be 2 or 1. 1 has to be 1 at all times. 14 can't become smaller than 14. 14 can't become 13 or 12. 14 can become 15, 16, or 17. And that movement needs to somehow combine such that they get paired with each other. So let's say you have 2 small numbers. Two numbers in the first half. Two numbers in the first half have to move themselves. It's like 4 and 7. This is 4 and 7 where the n is something big. So they both can move forwards. They can both become like 1, 2, or 2 and 6, 4 and 6. 4 can't be getting larger than 4. 7 can't be getting larger than 7. So, and they have to be on opposite sides. So 7 will probably want to move to become the biggest it can. So it stays 7. And 4 wants to move so that it is, well, what does that mean? 7 wants to move to the biggest it can, and 4 wants to just match where 7 is when 7 is as big as it can be, which is 7. Yeah, okay. 7 definitely needs to move bigger. And 7 can only move bigger when 7 is closer towards the bigger end. 7 can only move smaller when before that. So 7 would stay 7. I'm thinking about here the earliest it can be. 7 would stay 7, so that eventually 7 is the bigger half, and 4 is the smaller half. And at that point, the next round should guarantee that it should work. I guess 7 could become the biggest and 4 can be the smallest. If they're both small numbers, then they just wouldn't work. So let's say n is 17. So the rounds is round 17, 9, 5, 3, 2. So 17 is in the first half of this one. So it can't go bigger, so it probably wants to stay 7. 17 is in the second half here. So it should just, yeah, it should just, if it doesn't get paired with 4 immediately, then it should be able to figure out where it moves in the next round. Maybe. And then 17 gets paired with 4 in this round. I think. So if in the second round everything had 1 that was smaller, then 7 doesn't naturally get paired with 4, but 7 should be able to become the biggest here, and 4 should become, should be possible to become smaller here. In the next one there's 5, so 4 is actually going to come in the upper half. That 4 could be in the lower half as well. So if 4 is in the lower half, let's say 4's. Well, it can't be the first because 7 can't be the last, I don't think, because that's mutually exclusive. So 4 can be second to last, second to first. I think 7 could be probably second to last. So like maybe it was 2, 4, 7, 2, 4, 5. Actually, I think I need. Yeah, I think I need another number here. So let's say 17 is here. And then 4 would become the second to largest, and the 7 become the. Actually, there can't be 3 numbers in between them. So I think 4 has to be the third largest, and 7 has to be 5 numbers. So it has to be something like XX 4 X 4X 7X. Yeah, so it's like 5, 2, 5, 2, 9. Hmm. Do 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 do. Oh. All right, I think I'm gonna take a break here. This thing is surprisingly difficult, even though it seems pretty straightforward. But yeah.